in 3, 2. All right, 7-2 for Algebra 2. Today's date is Tuesday, January 5th, 2021. Our objective today is to, Andres.
Me. Converts a word problem into an exponential equation.
There it is. Equation. There it is. So I forgot to say this also before I started the lesson, but your camera needs to be on unless you private message me or just tell me right now. If your camera's off and you haven't had an excuse, then you are starting to lose points as of today. Today is the start of our behavior points. So please, please, please have that on, unless, again, there are a few people that have already talked to me and you're already okay. You're not gonna lose points. So our general formula. This is the same thing that we saw last time. And again, this f of t, it could be rewritten as t over time. I just had it as a general function, but usually this exponent, this power up here, is a fraction, especially for these problems today. I think every single one of them is going to be a fraction. I should change that for next year. Let's change that to a fraction for next year. Green is my way of saying change that. All right. Names of these variables. What is the name of A and the name of B that we gave them yesterday? Anyone remember? Pull out your notes if you don't remember. Well, if you took notes, or maybe you just remember. Wyatt, what's one of them?
Would A be like the initial value, like the start value?
Initial value, and I like your synonym start value. Start value. Perfect. You're correct. What about B? B was even more important. Sorry, Wyatt, I'm gonna call it someone else. Yes, dark face person. Who are you? Fernando, yes.
Is it scale factor?
It is indeed. It's kind of the scale factor. So what scale factor? I think that's what we called it yesterday, right? Scale factor.
I think that's what we called it, yeah.
Yes, we did call it that yesterday. I was thinking of the other word. Did I talk about the other word yesterday? I don't know if I did. What was the other word?
It was the base.
Base, there it is. And there's a third word too. I'll teach that as well. This is called the common ratio. Synonyms everywhere. Now I can say any of these words and you'll know what I'm talking about. And again, you have a variable t in the exponent, therefore it's an exponential function. And usually if you have some sort of weird time thing happening, you can make that the denominator depending on what your interpretation of that is. And we talked about that in 7-1. If you need to review, the video is already online. All right, so example 1, I need a reader. Beautiful voice. You all have beautiful voices, so all of you can participate. Who would like to read? Anyone? Yeah, Jenny.
Okay, is that bacteria or what is that?
Bacterium, you got it.
Increases its mass by 34% every 4.3 minutes. If the initial mass of bacteria was 83 grams, write a function that models its mass every t minutes.
There it is. Thank you. Essentially, we're just plugging all of these numbers and we have to manipulate one of them into this equation and we're done. So let's look at A. That's the first thing, the farthest thing to the left. Its initial value at start. That is a number. We don't have to change that. What is that number? I'm hoping over half of the class is going to raise your hand, and if your camera is off, digitally raise your hand. This is easy. What is the start number? What is the initial amount? Is it 34%, 4.3 minutes, or 83 grams? One of those numbers is correct. The other two are wrong. 2 people have an answer. Come on, more hands, more hands. This is a nice and easy one. I'm seeing 4 hands so far. I see Jose, Jenny, Charles, Wyatt. More hands, more hands. Come on, what is the start number? Read that again. Read in your head. What is the start number? There's another hand, there's another hand. All right, Jade, tell us.
83 grams.
83, yeah. 83 is the initial. It says the initial is 83 grams. Perfect. Let's do the next number, which is the hardest piece, the scale factor, the base, the common ratio, this letter B. This is going to be 83 times a number. And I have to be careful about this. I can't just plug in that number because it's a percent. And then again, we have to convert from a percent to a ratio. Charles, help us out, please.
So you would convert 34% into 1.34.
That turns into 1.34. Can you briefly talk about the process of getting that correct answer of 1.34?
To get
a decimal to a percent, you have to subtract it by 1 and then multiply by 100. So for here, wait,
Yeah, that.
yeah, and so I
that was
added
the
1 and then divided 100.
yeah. So you will. It used to be divide by 100, so now we're gonna. Or yeah, you're right. We used to multiply by 100, so now we. Shift C. We divide by 100, which means decimal place goes. If I had 34, it goes boom, boom. Arrow to let you know it goes that direction. So we get 0.34, and then we add 1. So it is 1.34, and then that gives you 1.34. Perfect. So that is our base, our scale factor, our common ratio, whatever we're calling this thing. And then we just need to figure out what is the exponent up here. Any idea on what we should do for the exponent? One person has an idea. Anyone else? Two people. Oh, Brennan's hand still raised from the last one. But yeah, let's go with what?
I think the exponent would be 4.3 times t.
4.3 times t. All right, so that is actually incorrect, but let's talk about why. So in theory, if we plug in 4.3 minutes into the value of t, then we should have this piece be 1.34, because that's what it means. Every 34% increase, 1.34 every 4.3 minutes. But if we plug in 4.3 into t, we get like 16 or 17 for this power when we want 1 for that power. We want this thing to be 1 whenever I plug in 4.3. So try again, Wyatt. What would that exponent be? Instead of multiply, do the other operation.
Would it be t over 4.3?
4.3. Okay, well let's test that. You're correct, and let's see why. If I plug in 4.3 into t now, then I get 4.3 over 4.3, which is 1, which means I get 34% more every of those minutes, every 4.3 minutes. So that one does make sense. And as a general rule of thumb for today's entire homework is just always divide by the time, because there's no tricks here. In our previous lesson, there was a trick. And I know that on the test that you're gonna have like in a few days, it will be tricky. Like, do I multiply or do I divide? Is it divide by 4.3? Is it times 4.3? Again, always do the logic of plug in the number that it's giving you, 4.3 minutes, into the value of t and see if you get the correct scale factor. In this case, our scale factor should be 1.34 after plugging in 4.3. So the only way to do that is by dividing. All right, let's try another one. Another beautiful voice, example 2. Jade, yeah, go for it.
The population of a city loses 1/14 of its population every 3 months. If the initial population was 16,342, write a function that models the population every m months.
There it is. Okay, so we have 3 numbers, and those 3 numbers are going to be plugged into our equation. Let's start with the easiest one, the initial value, the capital A in our previous general equation up here, capital A. Any ideas what our initial value is? Quiet raise hands. Jose?
The 16,000.
Yeah, 16,342. Perfect. And that's going to be multiplied by our scale factor, our base, our common ratio, whatever you're calling this thing. What is the number that goes here? And this is the hardest piece, so be careful. If you said 1/14, you're on the right track, but that's not the right number. One-14th is somehow affecting its rate, but how? Charles, talk to us.
Would it be divided by 1/14?
What do you mean by divided by 1/14? Like 1 divided by 1/14?
Like 16,342 divided by 1/14th. Because it would be, instead of getting bigger, it would get smaller. So
That's a valid argument, but the problem with that is if I divide by a fraction, I'll have to use the rule
Oh.
keep it, change it, flip it. And that's
think-
really multiplying by 14, which is that's growing. That's not good. That's
yeah,
too big.
so it would be -1/14 then.
That would mean that every single time that you have a value of m, that it will flip flop between a positive and a negative number, which is not exactly what we want to have happen.
Okay, well, that was my assumption.
It was a good guess, but you're going to go back to your original rule. Let's get some help for Wyatt.
Would you multiply that 16,342 by 13/14?
You do. How'd you get that?
So if it loses 1/14 of its population every 3 months, then we know that 14/14 is 1. So it'd just stay the same if it was 1. So I subtracted 1/14 from that because you're losing it. So it's 13/14.
So you had 14/14 minus 1/14, and you got 13/14. There it is. And this is the same rule that Charles said in our last problem. Like we have to convert it to a decimal, which you don't have to. It's already a fraction. And then you just add 1. Well, we had -1/14, add 1, which is the equivalent of doing 1 minus 1/14. And then you have to do a little bit of trickery to make sure you have 14/14 for common denominators, and you do indeed get 13/14. But either way, you're doing these same steps of make sure you're just adding 1 to whatever that number is. Make sure it's not a percent. And it wasn't a percent, it was already a fraction. And it was a -1/14 because it's losing 1/14. So this is exponential decay, not growth. All right, cool. We have the first two pieces. I haven't used the number 3 at all, and I need to do that. So what is the exponent up here? And this is a nice and easy one. Remember that our variable is m, and then how am I going to use the 3? Andres?
M over 3.
M over 3. And you're correct. Let's make sure that that makes sense. So that means if I plug in 3 into the value of m, 3 over 3 is 1, and then we have the correct scale factor. So that works. Perfect. All right, on to example number 3. And maybe I should pause here. Can you guys give me a fist of 5 on example 1 and 2? How well are you understanding what I'm saying here? 4, 4, 4, 3, 4, actually 5, 3. Chat popped up. Chat says 4 and then 3. Okay. And if you have questions, please ask. I'll give you time to ask questions while you're working on homework as well. Example number 3, another beautiful voice. If you haven't participated, I am going to call on you, or you can volunteer. It's not going to be someone that's already participated. All right, Jessica, you're up.
In fall, the number of blooming flowers decreases by 14% every 5 to 6 days. If there were 345 blooming flowers to begin with, write a function that models the number of blooming flowers every d days.
Thank you, thank you. All right, and by the way, this is our last example. We're done. There's nothing after this. So we have our problem. Let's zoom in. What's our first number, our initial number? A lot of people have answers. Someone I haven't called on, Gunner. And you can type in chat too if you want, Gunner. What is our initial amount? Or you can use your voice. What is the value of capital A? Our starting amount number, Gunner. Are you there, Gunner? No, okay, well, don't know if he's there. Let's move on to Sergio. You can use chat, I know, and you're listening. Sergio, what is our initial amount? Oh no, are you there, Sergio? This is the problem. Okay, he says hi with a direct message. Sergio, what is the initial amount? What is our capital letter A? And you can post to the group if you want, or you can post it privately to me. Either way, I'm going to say it out loud though. It's not that. So it's not 14% because 14% will affect your common ratio. It'll affect this number over here. So guess again. What is its starting amount? And I'll help you out. Begin, this word usually means start. Yeah, there it is, 345. 345, perfect. I need another volunteer that's not Charles or Wyatt, who've been doing the heavy lifting for this hard piece. How am I gonna use 14% to make a number here? Yeah, Andres.
I got 1.14.
1.14, you're super close. So you converted it to a decimal, you got 0.14, pretty good. But the problem here is this word decreases means that's a negative 0.14. So how does that change your answer?
Negative 1.14.
So you did 1 and then you did an operation plus 0.14, which we don't want the plus, we want a minus. So you have to do 1 minus 0.14.
So would it just be 0.14?
1 minus 0.14 is 0.86.
Negative 0.8. Yeah.
It's just a positive 0.86. Yeah, you should never have a negative base down here because, as Charles and I were talking about earlier, that'll make your number flip flop between positive and negative, which doesn't make sense for population. Wait, the population is negative? What does that mean? They all died and turned into zombies? I don't know. All right, we did the hard part, and then finally the exponent. That's a nice and easy one. Is Cohen there? Who is this? Is this Cohen? Is there? Cohen, give us the exponent. You can either use your voice or you can type in the answer. What is the exponent? You're the last person that needs to participate today. Are you there, Cohen? I want to give you a chance to participate. Cohen, are you there? What is the exponent for this equation? Okay. He needs help. Who can help Cohen? Jose is going to help you.
So would it be D over 5.6?
It is D over 5.6. Yeah, and as I said today, the lesson's pretty straightforward. It's the variable divided by whatever the time is. And this is a unit of time, days, so it's going to be D over that 5.6. And we're done. That concludes our notes. Woo. All right, fist of 5 on our objective. Everyone needs to do this, even if you're doing it in the chat. How well can you convert a word problem into an exponential equation? I'm seeing 4.14 from Andres, a 4 from Fern, a 4 from Cohen, 5 from Charles, 5 from Wyatt, 0.86 from Andres, 4 for Jose, 3 for Jenny, 5 for Jade, 4 for Jessica, 30 for Gunnar, or is that an okay? No, it's a 3, got it. All right, cool.